Okay, hi guys. Today I'll be discussing you probability distributions using Minitab. So I'm currently using a Minitab 19, the latest version of Minitab. Let's first have a short lecture here. Z-score. The Z-score is a standardized value which allows us to compute the probability of being with certain distance from the mean in units of standard deviations. And this allows us to compare the tail areas for different normal distribution. Here is the formula for getting the z-score, which is equal to x, which is the point of interest, minus x bar or the mean, divided by s or the standard deviation. And this will give us a value of a standard deviation in the standard normal curve. The z-score can help us to determine the probability that a value of a random variable will fall between 2 points on the curve by calculating the area under the curve between those 2 points. It could be a 2 specific point or 1 point and the other tail end, which is either negative infinite or positive infinity. So why do we want this? It is helpful in predicting the capability. And how do we do this? We can find the points on the standard normal distribution that correspond to the value of interest, and we can determine the area using the standard normal curve that is between these points. Now, let's get straight to the point. To understand better, let's check the sample problem. Gon's historical score on his exams in algebra averages 85, with standard deviation of 5 and follows a normal distribution. Find his probability of getting a score of 75 and below. So to get this probability, we'll follow this solution. First, we will use the formula for z-score, which is x minus x bar over s. The value of x or the point of interest is 75, the mean is 85, and the standard deviation is 5. Thus, we will arrive at a z-score of negative 2. And to determine the probability of x with a value of 75 and below, we will use the z-score from the z table. So here is a z table, and the equivalent value for of z equal to negative 2 is equal to 0.0228. And that means the probability is 2.28%. Now with Minitab, we don't need the z table anymore. We can directly calculate the value needed, and we don't even need to calculate the z-score. So how to do this? Go to calc, probability distribution, and select normal, because it's stated there that it's a normal distribution. Now we are focusing on the cumulative probability. And in this cumulative probability, that is actually the value of 75 and below. So we'll just input the mean, which is 85, standard deviation of 5, and we want to input the value of 75 and below. So that will be an input constant, which is 75. In this calculation mode, it's always referring to the left tail or this figure shown here. So we'll just click OK. And now we will be able to easily get the probability of x less than or equal to x, the point of interest, which is 75, and the value is 0.022751, and that's actually the same as what we have got using the Z table. Now, if we want to double check the answer, we could actually do it in reverse. We could use the same data, but instead of getting the probability, what if we know that the probability is 2.28% and we want to get what will be the value or equivalent score with a probability of 2.28%. So thus we will use the inverse cumulative probability, and we will type in here the probability, which is 0.022751 to be exact. We used the output a while ago. So click OK, and there it will return the value of 75. Now there's another way to do that by using graph. and then probability distribution plot. And we want to view the probability, so we'll select this fourth selection here. Click OK. So there's a window that will pop out. It will need to specify the distribution, which is at default is normal. We just have to input the mean 85, standard deviation of 5. Then go to the second tab, the shaded area. We are after the probability and we are given with the X value. And which tail are we focusing on? So the advantages of using this probability distribution plot, one is that you can actually select which tail specifically you want to get, either probability or the X value. And you could actually select even the middle, which is faster. And you will have a graphical view also. Now we are focusing on the left tail. Input the value of 75. Click OK. And there we will have this output. So there at the a value of 75, the probability is shown here, which is 0.02275, which is the same as the previous answer that we've got. And it even shows here the whole picture of that plot. So that's an easy one using that tools. Now let's go to another sample problem here, which is more interesting. The point of interest on a standard normal curve are 42.4 and 50.8. Now we have 2 points of interest here. What is the probability for these points of interest given a process with the mean of 40 and standard deviation of 8? So therefore, we are after the probability between 42.4 to 50.8. We'll directly use the probability distribution plot here and view probability. We'll just enter the mean of 4, 0, and standard deviation of 8.0. Now this will be easier since we have an option here, which is the middle. And we have two values to be entered, the lower value, which is 42.4, and the upper value, which is 50.8. And then click OK. So there, we will directly get the answer of 29.36%, or 0.2936 with this graphical view. Now, if we will gonna use the probability calculation here, it will be longer since we need to calculate for the value at 42.4 first, then another probability at 50.8. Then we will get the difference between those two probabilities and we will be arriving at the same answer. So that would be all. Thank you.